How far did you get in physics? Because you said that you were studying it, right?
I dropped out when the professors were making me do dumb things for hours for no reason.
Are you talking
When
about
the
homework?
matrix blocks it, like what's the point of that? I can go on Google. It's
Are you talking
dumb.
about
Waste of
homework?
time.
You dropped out because the homework was too hard?
Yeah, I had access to Google. Why would I waste my time and if I want to learn doing these like jumping through hoops like a monkey for a cookie when I can just go on Google and talk to the PhDs right there? It makes no sense.
Do you understand, um, how you get to the grocery store, on Saturdays?
No, everything's a miracle.
Do you
That's
understand
my
anything?
point, bro. No, nobody does. Neither do you.
Wait
That's
a
my
minute.
problem with
Hold on.
science.
Just to be clear, Jordan,
Pretend like you
I'm
understand
willing to
everything,
grant
but
that you don't understand anything. I don't think that you
don't
should
either,
assume that
bro.
about anybody else.
It's obvious. You don't know what you are. You don't know where you came
I
from. You
think
don't
that
know
you're
where you're
just
going. You don't
impugning
know
your
what you're
lack
made
of
out of. You don't
understanding
know
on
what
other people.
you're just pretend. Your whole worldview is pseudo. It's pseudoscience. You pretend like you understand, but you don't. And that's my problem with science. Is oh, what are you? Oh, I'm a bunch of quarks. What are quarks? Oh, I don't know. It's a field. It's a thing. A field thing. It's space. It's points in space. What's space?
It
Oh,
sounds
I don't
like,
know. It's over
Jordan,
here. Look, I'm pointing at the quarks, guys. Woohoo!
it
Come to
sounds like your
Quarkland with
entire
me. We're
view
gonna
is
go.
based on you not understanding things, and therefore nobody could understand things. Because you think that you're the
You
smartest
don't.
person in the world, and if you don't understand something, it must be impossible, and everybody else is just being dishonest.
And you think if you pretend like you're super smart and you have a doctor beside your name and a PhD, oh, I must be smart. Look at me and all my smart friends are going to school together. Look how smart we are. We're come follow me. I'll take you to the
Am I
promised land.
intimidating
Oh,
for you,
science
Jordan?
is so great, guys. Come along. Like
Jordan,
the
am I
Pied Piper
intimidating
calling
you?
the kids into the cave. Woohoo! Come here, boys.
Is my education intimidating for you, Jordan? Because it doesn't have to be. Jordan, how's it
Hello.
going?
Good, you?
I'm doing all right. How old do you think the Earth is?
I would say we're almost at 6,000.
And why so?
I mean, I guess ultimately, I don't know. I found I lost a lot of faith in science throughout my years. I find a lot of it, like I spent a long time looking for like fulfillment in science and like actual deep wisdom, right? And like trying to understand how the world works. And I ultimately found it very disappointing. It left a bad taste in my mouth because science had been exalted as like, this it's everything. If you want to be smart, you got to be a scientist. The smartest people are physicists, and I wanted to be smart, right? But ultimately, I was like, okay, none of these people really think deeply. And if they do, they don't even have a deep understanding. The deepest, you guys are smashing particles together, but I mean, you can keep smashing for infinity. I mean, how deep does it go? Like your understanding is never really going to get that deep. You're going to unalive before you have any real understanding of how the universe works. And then what? And then all of your science is
How
worth.
do you?
And so anyway, so
So
I spent all that time with science, and then and then I started reading the Bible instead, and I was like, this gives me hope for a future.
so when you talk
You
about
know?
like deep understanding, you just mean like things that make you feel good?
No, I mean like I was literally studying physics, trying to understand how the universe functions, and
And what'd
ultimately,
you learn?
you guys huh?
What did you learn?
Ultimately, you haven't gone that deep. You know?
How do you quantify that? I mean, like, I would say that we definitely understand more, and we know more deeply how the universe works today than we did 150 years ago.
Yeah, but there's still so much that we don't know. I mean,
How do
what's
you
the
know how much we
smallest
don't know?
scale? Because you can just go on Wikipedia and look at
Mm-hmm.
what the smallest particles are and how they function, and still nobody really knows. You guys just
So
you put labels on
let's
stuff
say
you
we go on
measure, and
Wikipedia and we look at what the smallest particle is. What do you think it'll say?
it'll, I don't know, it'll be like leptons, quarks, all those.
Mm-hmm.
You guys just put labels on a million different things that you've measured. I mean, I don't
So
know
those
why
are
you need
names of things. You asked for, or you suggested that we look up what the smallest particles are, and then you came up with a list of names of what the smallest particles are. So I don't see what the question is. Where's the
But you
issue?
don't really understand. It's not very deep. It's still very shallow understanding because those particles could be made up of other things that we don't understand yet. I
I
mean,
mean,
that's
you're
the whole point of
speculating. Like
CERN.
maybe that is the case, but maybe not. So
Exactly. You don't know, right? You
wait
have
a
no
minute. So
idea.
how do you know that the understanding's not deep? It could be that this is the end, and that we actually understand everything.
Oh yeah.
Right? It's possible.
So I guess CERN should just stop everything.
I didn't say that.
We did it, guys.
What I'm saying is that, or
or
rather, alternatively, maybe the next discovery is the last one. Maybe that's like the final piece of the puzzle, and then the whole story's done. You come on here saying like, oh, you don't really understand anything. You don't understand things deeply. You don't really know anything. You have no way of quantifying how much we know. You have no way of evaluating how much we actually know. It could be that we know 99% of it, or it could be that we know 1% of it, and you have no idea.
And neither do you.
But you're the one making the claim. You're the one making the claim that scientists don't know anything, that they don't have a deep understanding of everything.
Do you think you have a deep understanding of reality or not?
I think that depth is a relative measure. I think that our understanding of reality now is significantly deeper than it was 150 years ago.
But is it compared to the totality of all?
We have no idea what the totality is. Neither do you.
You have no idea. You have no idea if you're deep or not, really, right? It could be. You could
You're
be
the
deep,
one.
or you
Look,
couldn't
I
be.
never
You have
made.
no idea.
I never made the claim that we have a super deep understanding of reality and we're almost at the bottom. You're the one who came in and made the claim that they don't have a deep understanding of reality. So can you back that up?
You don't think science broadly has the idea that they have a deep wisdom that like if you want to be smart, you go into science because science claims to have all these deep insights about how the universe works. And I'm saying that claim after investigation doesn't seem very true to me because it could go infinitely deeper.
So look, is your contention that like science promised you all of the answers and then you started getting into science and oh look, you don't have all the answers? Is that your contention?
Yeah, I thought I would be learning like valuable, deep. Yeah, I thought I would have a deep understanding of reality.
Can you explain what you mean by deep understanding of reality? What do you mean by that?
I mean getting close to a full understanding of how reality works would be.
And how do you evaluate how close you are to a full understanding?
Getting to the bottom of it.
Will you know that you're at the bottom until you're at the bottom?
No.
Okay,
that's the thing.
So are you telling me that, just to repeat what you said that science doesn't have a deep understanding of reality. But now it sounds like you're telling me that you actually don't know how deep of an understanding of reality science gives you.
And yeah, okay, but you're missing the point. The point is that like if it's possible, the fact that it's possible that it could be infinitely more deep, right? Just shows how far away you are. You could be, okay, you don't know. Maybe we could be right there. Okay, yeah, sure. Yeah, you really think that?
How do you know it's possible that it could be infinitely deep?
Almost there? Does it feel like you're almost there?
How do you know that it could be infinitely deep?
You're saying it's not? You disagree with that?
I'm asking, you made the statement that it could be. I'm asking, how do you know that it could be?
Oh, okay, sorry. Okay, so maybe I'm wrong. Do you think I'm wrong?
I think that you should back up your claims rather than just throwing things out willy-nilly.
Well, I mean, I think it could be. I mean, it could be infinite. There's a lot of things that
on what grounds?
Is it not? Okay. If you think I'm wrong, that's fine. You don't think it could be infinitely deeper? Do you?
I just want you to justify the claim that you made.
I don't. Maybe it's unjustifiable. I don't know.
So, like, you came in.
Why don't you give me an equation and figure it out?
So, are you telling me that the reason why? So, you studied science, which, you know, believable or not. You studied science, and then you had some thought with no justification to come to the conclusion that, oh, well, you know, it could be that science is like not deep at all. Therefore, science must not actually be deep. Like it seems like you had some subjective vibes-based feeling. You impugned that on the entirety of the scientific method, the scientific community, etc. And then you use that to come to a conclusion that science actually doesn't know anything, even though the origins of that position stem from vibes.
I'm not saying science doesn't know anything. I'm saying what it does know isn't that impressive.
I don't know. I would say knowing how the Earth got here is pretty impressive. I would say knowing what knowing what antimatter is impressive.
Go ahead.
Sorry?
You know how the Earth got here. Yeah.
Yeah, it
Okay.
formed gravitationally in an accretion disk around a forming star.
Oh. Oh, really?
Uh-huh.
Yeah. What's the Earth? What's it made out of? Particles that you don't...
Made
just
of
a bunch of
rocks.
particles, right?
It's made of mostly
Rocks.
mostly iron.
And rocks are made of
mostly-
atoms, and atoms are made of quarks, and quarks are... You have no idea. Woohoo!
We do know what quarks are.
Yay,
They're
you're a
excitations of a
scientist.
field.
A field of what?
It's called the quark field. Top quark field,
Oh,
bottom
what's the
quark
quark
field, down quark.
Tell me.
It's a fundamental thing.
Yeah, what is that? Because you're so deep. Your
a
understanding is
fundamental
so
thing.
deep. Tell us what a quark
That's
is.
the bottom.
Oh, the quark. How do you know that? That's a baseless claim. Back it up, please. Go ahead.
That's what the evidence points to.
And is that okay? Wait. So
That's how we do science. You
your-
come to
your-
a conclusion
your
based on
claim is that-
evidence.
what is the quark field again?
It's a fundamental thing. It's not made of anything, so we can't say that it's like made of something
it's a thing,
smaller.
guys. A quark is a thing. Everybody, yay!
I was
science.
in
Go
the
ahead.
middle of a sentence, but so the quark field is, I mean, you can describe it mathematically if you want. I don't know if that might be over your head. But the quark field is
yeah.
I mean, if you don't, do you understand what the word field means, or do you want me to explain what a field is?
A field of what? Quarks?
Do you want me to explain what a field is?
Woo,
Do you know what a
wow.
field is?
It's like a coordinate system, basically.
It's not really. It kind of lives on top of a coordinate
340
system.
coordinate system. Yeah.
It lives on top of a coordinate system, so it takes in
It's
as
something
input.
you made up in your mind. Yeah.
No,
Go ahead.
so I certainly didn't make it up. I think
It might accurately reflect reality, but you're not sure
Poisson
because you don't even know what a quark is.
Well, no, I mean a quark is an excitation of the quark field. Look, the point is that
What's the
I
quark
can give you
field?
answers. So Jordan, I can give you answers about things, and you could just keep asking why, and then sure, eventually you'll
You didn't
get
give me an answer. What's the quark field? You said it's a
the
thing,
quark field
bro.
is fundamental. That question
it's fundamental?
supposes that it's made of something. But if it's not made of something, if it's
Or
truly
something.
fundamental,
It's something,
then
guys.
it's
Everybody.
not.
The quark field is something. You heard it here first.
Jordan, look, the quark field is a
You have
field.
no idea
It
what
has
it
certain
is.
properties.
Just admit it, bro. This is
we
why
can,
you're
we
shallow.
can perfectly well
This is what I'm
describe the
saying.
quark
This is why
field.
you're shallow. This is as deep as you got.
Do you know what a field
This
is?
as deep as your understanding goes. It's
Do you
a
know
thing.
what a field is?
I just told you it's a coordinate system. It's a model that you made up in your mind. Yeah, that's what a field is.
Wait, so is your contention that like, the models and the reality are perhaps not the same thing?
How would you know? Why would I
Look,
believe
why are you asking me a question? I asked you a question. Can you answer it?
reality? You don't even know what your model
Can
is.
you answer the question? I'm trying to have a super good faith conversation with you. You just seem like you're
You're
rage
dodging
quitting
'cause you don't know what
every
a
single
quark
question I
field is.
ask you.
That's what you're doing. You're asking me what a quark field is because you don't
I'm
know.
not asking you what a quark field is. I'm asking you
Tell us
if
what
you
it is,
know
then.
what a field is.
Why?
Because if you don't know what a
I gave you my
field is,
definition of what a field is.
Jordan.
You can give yours, I guess.
I have to mute you. I'm sorry. Look, I am asking you if you know what a field is, because if you don't know what a field is, that's fine. I will just have to explain it to you to explain what a quark field is, because a quark field is a type of field. And so I'm asking a clarifying question to make sure that I don't need to explain something you already understand.
Okay.
Got it?
You can give your definition for a field.
Okay. A field is an attachment of properties to every point in spacetime.
Yeah, so a coordinate system, just like I said, the points are coordinates.
But no, it's not a coordinate system. The field is the properties that are attached to every point in spacetime. But, hopefully you understand that. And then the quark field is a specific
How do you define the
set.
points with a coordinate system?
The quark field is a specific set of properties that are attached to every point in spacetime. And we can give those
these points.
give names
Where
to
are
those
these
properties.
They're in your head, right? You just
Points?
you scribbled
Points are
them on paper or
places.
computer programs.
Points are
Where are these
places.
points?
They're like here and there, and
How do you define where the points are?
you can point to them if you want to.
Oh, where are they? Are they in reality, or are they just in your model that you made up in your head?
Points are
Like I
like
said.
places. Do you think that places don't exist?
I mean, you're the one saying that they exist. I don't know. You're the one saying
You don't know
you're
if
saying these
places
fields
exist. Wait,
Where
you
are
don't know
they?
if places
Where are these
exist?
points? Point them out.
Yeah, here, I'm doing it. I'm pointing them out right now.
Okay, and that's a quark field.
No, those are space-time points.
Okay,
The
where's
quark field is attached
What
to
is
each
it?
point in space-time.
Okay, and so
it
the quark field
attaches
is...
properties to each point in space-time. That's what the quark field is.
Okay, so the quark. Okay,
Okay.
a quark
so
field
for-
is what is it's points in space?
No. I've explained this now 3 times. Can you just listen rather than just assuming that I'm saying points in space? The quark field is the attachment of a certain set of properties to each point in space.
It's so the attachment of properties to points
Mhm.
in space.
Yep.
So, okay, so everything, the Earth, everything is made up of attachments to points in space. Of attachments
view it
of
that way,
properties
yeah.
to points in space, right?
I mean, the way that we could describe the Earth at its most fundamental level would be a set of properties at each point in space, yeah.
Okay. What is space?
The thing that you're standing in or sitting in.
Okay, so the Earth came from space.
The Earth
How
is
did
in
it do that?
space.
Well, you said, I asked where did, or oh yeah, wait, no, you said
So,
where does the
and
Earth
just to be
come
clear,
from?
this is like completely irrelevant, because the point I
You
was
said
making
you
at
knew
the
where
very
Earth came
beginning,
from, and you, so you're
Jordan,
saying it came
the
from
point
space?
the point I was making initially is that questions about like how the Earth formed, we now know the answer to, and the ancients absolutely didn't know the answer to that. Now we might not know, what's the fundamental nature of like microscopic black hole, but that's not relevant to asking, well, how did like the Earth is made of rocks, but it's a big ball made of rocks. How did those rocks come together? We now know the answer. The ancients didn't know that.
It just magically appeared in the quark field one day. Just walking down the street, boom,
I don't know
Earth.
why you're being so bad faith here. Do you agree that we know
Because you
more
act
about
like you
how
have
the Earth
knowledge.
formed than the ancients
That's my
did?
problem with you guys. You act like, oh yeah, we know where the Earth came from. Oh, I'm Mr. Science Man. I can tell you where the Earth. No, you can't, bro. It's a mystery.
Jordan, I just gave you the answer. It formed gravitationally in an accretion disk. That is an answer to the question of how did the Earth form?
Okay, sure it did, bro. Like what? See, that's the thing. If you make statements like that are so unverifiable, then every statement you make is just
Why do you
garbage.
think that's unverifiable?
The Earth formed in an accretion disk. Okay, sure it did. Prove it. Go.
Yeah,
Were you there?
well, so science is in the business of evidence. It's not in the business of proof. You understand that, right?
I guess. You guys,
okay, so
nothing
all
you've
I
said
need to do is provide evidence that this is the case. Right?
Okay, well, I'm glad it's not proof. Yeah, so you haven't proven anything ever. That's
Science
good.
is not in the business of proof.
Great. You guys should stop saying that it is then, because you guys say
I never do.
Oh, so the age of the Earth isn't proven?
We have overwhelming evidence that the Earth is 4.5 billion years old.
But it's not proven.
Science is not in the business of proving. It's not in the business of proving things
so
true. It's in the business of proving other things. It's in the business of proving false things false.
I guarantee I could find like 5,000 scientists that would say we've proved the age of the Earth. But what
I think you guys speaking loosely. You're not talking to them. You're talking to me.
Yeah. Okay. Well, I'm glad.
So look, it seems like you're just dissatisfied that science isn't giving you all of the proof that you want for the questions that you think science should be able to answer. And like, fine, you can be like skeptical if you want, but then I don't understand why you would then turn to something that has no proof, has no evidence, and then believe that. It just seems inconsistent.
Because the way, I mean, okay, first of all, like, I don't think you really characterize what I'm doing quite right. Like,
sorry, I didn't hear you. I was drinking water.
It's not that like, it wasn't deep enough for me. It's just the fact that you guys act like it's so deep and self-fulfilling and so smart and great when it's not. It's my problem is like,
is this like a sociology issue?
As like, pardon?
Is this like a sociology issue? Like you're just upset that like people who study science act certain ways, and so you decided to believe something that's like demonstrably false?
No, that's a separate issue. I can get to why I switched to Christianity if you want. But
I agree that it's a separate issue. Go ahead.
Yeah. So, but I mean, I just think you guys act like you're so smart. Like the way the Earth was made in a accretion disk. Like, what? It was? You don't question that at all? Like, what?
People do question it. And then we studied it more, got better evidence, and then we all said, yeah, you know what? The evidence is actually really good. This is a reasonable thing to believe.
Okay, well, let's go to some like the relevant question here, which is the age of the Earth. Like, Have you really questioned? I don't think you guys really deeply
I've
question it.
looked at the evidence myself personally.
Okay, like one time?
I have the papers. I can show them to you if you want.
Have you questioned them deeply?
You read them, and that involves reading the methodology and checking to make sure that it's sound.
Right. Did you really checked? I just don't
I
believe you guys
literally
checked.
read
I
the
don't
papers. That's part of
all
doing
of
science.
maybe even like you might be the person who's on TikTok who has looked into this the most, right? And I still don't believe that you've questioned it deeply. But everybody else,
What does it mean to question it deeply?
else,
You see the evidence, you check the method, it checks out. You say, you know what, this is good evidence. Then you go look at other evidence. You check the method, you check the data, it checks out. You say, oh, this is good evidence too. I guess we have two good pieces of evidence. And you keep doing that, and that builds your credence in a position. And eventually you come to the conclusion that my credence should be very high in this particular view because the evidence is strong for it.
Do you think most people that believe the Earth is billions of years old study it deep enough and actually question it deep enough to have a legit opinion on it?
I think that most people who are not involved in science, if they want to believe true things, they should generally, like, if they want the best odds of believing true things, they should generally just go look at what the scientific consensus is on some particular topic and then believe that. That's most likely to get them to the right answer.
Right. But that wasn't my question. Do you think people actually look into it deeply enough to have
no,
like
and I don't think that they need to. All that's necessary for a layperson,
right?
All that's necessary for a layperson is to just listen to what the scientific consensus is, and they will be right most of the time. That's just as good a reason.
Okay, so I'm glad. So you don't think so you think it's fine, which isn't what I asked. I didn't ask if you think it's fine that they just believe the consensus. I asked, do you think, like, and the obvious answer is nobody really looks into this. Everybody.
Well, scientists do, but lay people are not scientists. We don't have an expectation that they do this. No.
Yeah. So most people who promote the idea of the age of the Earth are shallow, haven't questioned it.
Most people who promote the age of the Earth are scientists, right? Those are the people doing writing the papers on the topic, promoting it.
No, there's tons of people on TikTok streaming and
wait,
they say,
hold on.
Science.
I'm sorry. I thought that your original contention was with like science, not like randos on TikTok.
Well, I'm using this to make a broader point. So, like,
what's your broader point?
The fact that people don't question the science when it comes to the age of the Earth generally, even though you might, which I don't believe.
Well, the scientists
the fact
do.
That people don't question
lay people don't.
it is an example of the whole scientific endeavor, the whole scientific community. They speak as if like, oh, we know things, like we're 100% sure, but they're actually most of the time very, very shallow.
Well, to be clear, saying we know things and being shallow, in fact, even knowing things and being shallow, are not mutually incompatible. Being shallow, that's like a weird subjective judgment that you're making based off of kind of vibes, I guess, but like it is the case that insofar as anybody really knows anything, we know a lot. And we have the scientific community, the scientific method to thank for that.
I mean, there's a lot of stuff, like obvious things, like I don't know, Newton's laws. Yeah, you can test that, you can observe that. But when it comes to the age of the Earth, you weren't there. There's a lot of things that are
your standard?
Easy to know.
You just don't but you have to be there in order to know that like the evidence points to something true. Is that your standard here?
I think being able to observe and repeat and test theories shows that they're correct, right? But you can't actually repeat unless you're alive for, I don't know, 1 billion years. You can't actually repeat it and test it.
But see, look, this is an issue because you don't hold yourself to the same standard for your beliefs. You're criticizing scientists for a set of beliefs. I'm trying to tear you guys
down before I build Jesus up.
So you're criticizing scientists for a set of beliefs which are based on evidence rather than proof. But evidence, that's what we do in science. Whereas the view that you hold, you don't hold yourself to that standard. Instead, you say, well, we don't need proof. We don't even need evidence. We just need faith. How can you not see the hypocrisy here?
I mean, because I think if you're going to go with a biblical worldview, today, I think, like specifically on the age of the Earth, I mean, probably the biggest mental block you'll have is the quote unquote science, right? It's like, how can I believe the age of the Earth? Like if you're like, it's the reason why it's hard to believe is because we have all these scientists that are saying like, no, 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 like you're dumb. The science proves
No, the reason why
age
it's
of the
hard
Earth
to
is
believe
way
is
older.
not because of the scientists, it's because of the science.
Right, sure. According to you, right, a scientist saying that, the science, quote unquote.
Well, I can show it to you if you want.
Yeah, I would love to. I think we'll look at how deeply you've questioned your methods, and I bet you haven't really done your due diligence at all. But my point was that like the biggest hurdle people have is the quote unquote scientific community in believing the age of the Earth. And so if you just throw that out into the garbage where it belongs, in my opinion, then it's a lot easier to believe the age of the Earth in the Bible.
I agree. If you throw out the entirety of science, yes, it is easy to believe that the Earth is 6,000 years old. I agree. But
I wouldn't throw it all out. Just your dating.
Just the science that disagrees
generally.
with your faith.
Just the science that's not observable, testable, repeatable, right?
So to be clear,
like evolution,
do you think that we can observe?
These are just kind of like.
Do you think that we can observe, test, and repeat the decay rate of uranium?
Yeah, yeah.
Okay, so that's observable, testable, and repeatable. Do you think that we can use the things that we learn, the facts that we learn about observing, testing, and repeating uranium to figure out how long the uranium has been decaying for?
Over a period of 6,000 years, or no, I don't think you can extrapolate like that. No, I think that's
so.
A big
in
jump.
your view, you can't know anything
controlled in a lab.
So in your view, you can't know anything about how fast uranium decays when it's just sitting out there in a rock?
You don't know if it's just, you don't know what happened it's just sitting there on a rock. How do you know it's just sitting there on a rock?
Well, I'm asking you, if uranium was just sitting there on a rock, do you think that we'd be able to know anything about how quickly it was decaying?
Maybe, yeah, I guess. If it's on a rock somewhere, I don't know. Don't you do these things in a lab? I'm saying, I mean,
the whole business of science is being able to. So the whole business of science is about making predictions, right? And the better you get at science, the better your predictions get.
Yeah.
And so the point is you do a lot of science to pin down some features of the world. Say, maybe you're Galileo Galilei, and you try to figure out. You drop a whole bunch of weights from the top of the Tower of Pisa, and you figure out that it doesn't matter how much they weigh; they always fall down at the same rate. Now that was the experimentation, the observation, the testing that he was doing, and then he concluded that must be true about the whole world, that everything falls at the same rate, not just the weights that he dropped off of Pisa. Do you think that was unjustified?
Okay. No, I think I'm fine with gravity. Gravity I can see with my own eyes.
Well, wait a minute, but that wasn't the question. The question was, do you think it was justified for him to conclude that everything falls at the same rate just by testing, a few cannonballs that he dropped from the Tower of Pisa?
Well, not everything falls. I mean, what if you're in space?
Everything on Earth. That's why I said everything on Earth.
Oh, everything on Earth. I mean, at the time, I don't know if that would be justified at the time, because who knows? Maybe the gravity changes somewhere else. Like, how would you know if you're just discovering this phenomenon?
I'm asking, do you think that it would be justified to hold that belief? Not that it's like 100% certain. I'm asking, is it justified to hold that belief?
Today?
If you were Galileo, would Galileo have been justified in holding that belief?
I don't think so. Who
no,
knows?
You don't think so. So he dropped a whole bunch of different weights off of the Tower of Pisa. But actually, let me rephrase the analogy. You're not Galileo. Let's say you're his neighbor, right? So Galileo tells you about how he did this. He dropped a 1 pound weight, and then a 5 pound weight, and a 20 pound weight, and they all hit the ground at the same time. And he tried them with different sizes and different weights, and they always hit the ground at the same time. And then he tells you about this, and he says, so yeah, I've concluded that regardless of what you drop on the Earth, it'll always hit the ground in the same amount of time. It always falls at the same rate. And are you telling me that you would say, that's ridiculous, that's so unjustified, how could you believe that? You don't understand anything. Is that
no? No, I'm saying in the geographic location where Galileo discovered it, yeah, that would be justified generally. But they didn't even discover the New World yet.
He didn't test it in his house. He tested it on the Leaning Tower of Pisa.
Yeah, okay, but if at that time you're just discovering this phenomenon,
Hmm.
would you be justified to say everywhere on the entire planet has the same rate of fall? I mean, I wouldn't. No, at that time, maybe the gravity's different somewhere else. I don't think that's so crazy to believe. Like, they don't even know how big the Earth is. They don't know where the end of the Earth. They don't know anything at that point. So of course maybe they would be. Maybe there would be different gravities somewhere else. That would be totally plausible for you to think and to assume that it's the same everywhere, like the same rate everywhere on Earth. I don't think that's a valid assumption.
Would
I
it
don't
be
think that would be
valid for would
justified.
it be valid for him to infer that it's the same rate in his home as it is on the Leaning
Yeah,
Tower of Pisa?
yeah, that's fair. Yeah.
But he didn't test it in his home. He tested it on the Leaning Tower of Pisa.
Okay, but he's close by.
So
That's fair.
it sounds like what you're
but
telling me
even
is
then,
that we can actually use information that we gain from a laboratory experiment to infer the way that things will behave in nature.
but the rate could have changed at his house. He doesn't. You'd have to go test it at his house.
Okay, so
You
now
could
you're
maybe
saying that it
guess,
wouldn't be
hey,
reasonable.
maybe the rate's
Now you're
the
saying
same
it
at
wouldn't
my
be
house,
reasonable
but
for
you
him to
would-
believe that.
Yeah, I think maybe I gave the wrong answer. I think actually because I wasn't thinking of Pisa. So if he did the experiment at the Leaning Tower of Pisa, I
And
think
let's say his house is like,
whether the rate
down the
is the same
street.
at his house is up for debate.
Let's say his house is down the street.
Could be different. Maybe there's some gravity. I mean,
Right.
if
So
you're just discovering,
so in fact, if you were his neighbor and he were telling you about this, you would think that he's being unreasonable.
if he made the claim that I know for sure it's going to be the same rate
No,
at your
that's
house,
not
I
the
would say
claim.
that's
He said, yeah, so I did these experiments. I think I'm justified in believing, or rather, he just says, so now I believe that the rate at which things will fall in my kitchen is the same. That regardless of how much
yeah,
it
I would
weighs, it'll
say,
hit the ground at the
I don't know,
same rate.
maybe. I'd say it's probably pretty close, but I don't know if it's the exact same. If he said that, I wouldn't be like, yes, sir, it is the same everywhere on Earth
The
automatically.
question is not
All
the
hail
question is
Galileo.
not certainty. The question is it reasonable to believe?
I don't think so.
Okay. So, in your view, it's not reasonable to believe anything about the natural world based on any experiments performed in the lab.
Now you're straw manning.
No,
You took that way. No.
This isn't a straw man. I will tell you how I got to this conclusion. So the analogy points out that you think that you can learn something about what's happening at the Leaning Tower of Pisa, and that does not necessarily say anything about what happens in your kitchen. Because you said it's not reasonable to believe that it'll be the same in your kitchen. And so if that's your conclusion, that you can only know about the stuff that you explicitly tested, you can't then apply that knowledge to other situations, it seems like we can never make any predictions about the natural world. We can never make any inferences about the natural world because anytime we run a test, we're doing it in a laboratory environment or we're doing it in a controlled environment. We can never make predictions about things that we haven't tested in situ, which means that, we can't say that we can't say that a tornado is going to go in this direction because we haven't measured that tornado yet. We can't say that, this volcano will erupt in a day because we haven't measured that volcano yet. We can't make any predictions in a justified way at all. Sounds like.
So do you think that it's good to verify? Like, do you think it was good? Like, do you think they should have done the gravity test? Like Galileo should have done the test elsewhere? Or do you think just one was good enough?
To be clear, he didn't do just one. He was doing it on the Leaning Tower of Pisa with lots of different weights.
Do you think but Leaning Tower of Pisa, check it there. Don't check anywhere else. It's definitely going to be the same. So don't even worry about it.
To be clear, I never said that. The point is that it was justified to believe that it would be the same.
But do we have to verify it at all or no?
Who's we? Are you talking about scientists? Or are you talking about lay people?
Really. Or people who care about...
Scientists wanted more precision measurements, wanted to figure out how quickly things fall, what changes the effect, because, we did eventually find out that actually things don't all fall at the same rate, and we figured out that's because of air resistance, and, it got more complicated. But the conclusion is that, the first order correct conclusion is that, things on Earth fall at the same rate. And then there's modifications and stuff that we learned about more. But that would be absolutely...
Why would you double check it elsewhere? Why double check it at all?
It's not about double checking it. It's about getting better precision.
Yeah, why do that?
And by the way, you absolutely can double check it elsewhere. If Galileo checked it in two different places, if Galileo checked, let's play with your idea. Let's say Galileo did it on the Leaning Tower of Pisa, and then he did it on some other tower, like, I don't know, on the other end of the city, say, right? Would he then be justified in believing that things will fall at the same rate in his kitchen?
I mean, no, but you're not answering my question.
Look, so
why would you double check it?
Verifying scientific experiments is like part of the scientific process. You always do these things more than once. So I just asked you, what if he did it twice in two different places? Would he then be justified?
I don't think so. No.
Okay. What if he did it in three different places, but not his kitchen?
I'm genuinely looking at this example. No, I don't think if you're just I don't think you would assume it's the same everywhere. I don't think that's a valid belief.
So even if he does it in three different places, none of which are his kitchen, and he gets the same answer, he cannot then reasonably infer that things will fall at the same rate in his kitchen.
I mean, I think there's like a cone of uncertainty, like, yeah, like the geographical area. If you do it a few times in the city, maybe, yeah, that whole city is going to be the same. That's fine. But then to leap across the entire world and say it's going to be the same over there, I think that
wasn't my question. My question was about his kitchen.
Yeah, his kitchen. No, when you're no, I don't think so.
Okay, so it doesn't matter how many times you test it, unless you test it in the specific situation that you're trying to make claims about, then it's just not justified to believe anything about that situation. It sounds like.
Well, we're talking about gravity specifically. I mean,
we're talking about science. This is an analogy for the whole scientific process.
Your analogy is about gravity specifically, and
yeah,
I think
sure.
Maybe gravity has a unique potential for variability across geographic locations. That maybe like if you measure. I don't know.
By the way,
measuring
it doesn't.
Would be
so
more repeatable.
Things fall at the same rate everywhere in the world. Now, that rate that they fall out might be different in different places. That rate that they fall out might be different in different places. But if you take two things, modular air resistance, of course. If you take like a small lead ball and a big lead ball, they will hit the ground at the same rate regardless of where you are on Earth.
Yeah, I know, but how would Galileo know that? How would he know that?
So it sounds like you're saying that there's no way for him to justify that if he takes two different sized lead balls and he drops them in his kitchen, that they will hit the ground at the same time. There's no way for him to justify that belief unless he's actually done it in that place.
I mean, no, that's not. I already explained what I'm saying, but like, my point is that like the closer you are to, so if you do a test at Pisa, and then you do a test like,
a building a few blocks down.
You're probably gonna be like, yeah, it's probably the same. But if you're going all the way across the world,
nobody's talking about going across the world. We've narrowed the analogy, and we've been on a narrowed analogy for like 10 minutes now. Like,
but even if it's like down the street, it still could be different. So I don't think
you're telling me that if
I think you'd have to test it.
So
you have
Jordan,
to test it down the street too.
So you're his neighbor, Tony, right? Galileo tells you, yeah, so I tried it on Pisa, and these two hugely different lead ball sizes, so one's like maybe an inch across and one's like 6 inches across, they hit the ground at the same time when I dropped them from Pisa. And then I went to the Peening Lower of Misa a few blocks down, and I tried it again, and they hit the ground at the same time there too. And then I went to the Beaning Lower of Kisa, just a few more blocks down the road from that, and they hit the ground at the same time when I dropped them there too. Now I'm going to go into my kitchen, but I think if I drop them in my kitchen that they'll hit the ground at the same time. And you would say, nah, you can't know that. You're not, that's so unreasonable.
I would say probably, but you don't know for sure.
Would you say that it's reasonable for him to believe that?
No, I don't think so. Not at that point.
Okay.
No. Because for me, belief means like you're very sure, right? You're very sure that it's going to happen. And if it's only like the third test, who knows?
How many tests would he have to do without doing a test in his kitchen? How many tests in his town would he have to do?
Wait, how many tests in his town to know if his kitchen is the same? I don't know. Like, I don't know. Maybe I don't know. I don't know. I mean, can we take this to zircon dating, to like a real like real world application? Because I think there's like a
not until we
gradient.
finish the conversation about the Leaning Tower of Pisa.
I think there's a gradient of certainty because I would be thinking, oh, maybe there's like a gravity wells that like change the rate somewhere. I don't know. Well, actually, you know what? I guess people would have experienced gravity wells. So, but I don't. Yeah, no, I don't know. Um, I don't know. I don't know. 5, 7. Like, how would I? You know,
Okay, 5, 7, sure. That's enough to get you to
believe that
some
in
maybe
your local
95%
area,
or
sure.
something like this.
Yeah.
Okay, let's say
Okay,
7.
yeah.
Okay, so he has to test it 7 times. Okay. Do you think that standard is like reasonable for
Even then
like
you could be wrong,
other
but yeah,
scientific
sure.
things? Like if somebody tests, if you have like, 7 people testing something in different settings and they all get the same answer, that's reasonable to think that will apply in an 8th setting?
I mean, yeah, I don't know. I'm hooked on the word belief here because it's like,
Belief is just an attitude about a proposition.
but here's the thing. So you're using this to uh equivocate zircon dating, but I don't think it's a one-to-one
Equivocate?
comparison. I
Do you
think
know what
dropping a
equivocate
bowling
means?
ball in the city
I'm talking about
is a bad
uranium
analogy.
decay rates, right? We haven't even gotten
Yeah,
to zircon.
okay, uranium. Okay, well, you're talking about uranium. I don't think it's a one-to-one. You're using this as if it's like a one-to-one comparison to
Well, look,
uranium
you can
dating,
measure
and I don't think it is.
measure how long it takes for 2 differently sized lead spheres to hit the ground in Pisa, and you can do that 7 different times in different places, and you'll get that they always hit the ground at the same time. Similarly, you can go measure 7 different samples of uranium at 7 different times in 7 different places, and measure the decay rates and get the same answers.
But no, because
No.
you have a control. You have a laboratory control for the decay rates.
What are you controlling about the decay rate? It's just like a lump of uranium. What are you controlling?
You're taking a lump of uranium and then you're measuring the zircon. How much?
I'm not even talking about zircon. I'm just talking about
lead.
decay rates of uranium, how quickly uranium decays.
Okay, so you're measuring, but what does it decay into? Lead, right?
Well, not directly. It decays into lead eventually through like 10 or 11 or 12 different steps.
Right. So you're measuring this rate over time.
Mm-hmm.
You're I don't know how you're. I mean, what? You're using just uranium half-life to age things? I thought
We're not even there yet. We're not even there. We're just talking about
Yeah,
how
like,
long does it take uranium to decay? What is the half-life of uranium?
Yeah,
That's the
okay.
thing that we need to agree on before we can even move on. This is like something that like is consistently, or that is behaving consistently across time and space.
I guess. I don't know. Have you done it? Have you? I mean, it's probably the same, I guess.
I've looked at the data. I haven't personally done it. If me personally doing it is the standard required, then like, I don't think that you can believe anything.
I mean, I don't even. So you're saying you take 7 samples of uranium and you measure the decay rate. They're the same
No,
everywhere.
what I'm saying is you have 7 different groups of people, each with 7 different samples of uranium in 7 different places at 7 different times, all measuring the decay rate of uranium, getting basically the same answer.
Okay. Yeah.
And
Then the
honestly,
8
it's
will
probably
be
on the
the
order
same.
of dozens, if not hundreds, rather than 7, but 7 was the number that you said.
Yeah. So, yeah, there's probably a decent certainty. You're probably fairly certain about that, yeah.
Right, so it would be reasonable to say that, oh, if there was just like a uranium lump sitting out there in nature, we would be reasonable to infer that it decays at the same rate that we measured those 7 different times.
Yeah, I think so, yeah.
Okay, and what if would we be reasonable to say that 50 years ago it was decaying at the same rate?
No, I don't know.
What if we measured the decay rate of uranium over like many different times over like 100 years by different people, different places, different times over the course of 100 years, and you still get the same answer? Then would it be reasonable?
Well, it's definitely not going to be exactly approximately the same answer, I
like
guess.
within experimental bounds, right? Like every measurement has experimental error, so within experimental bounds, the same.
Yeah, I mean that's a pretty small time frame, like relative to the supposed age of the Earth. But yeah, like I guess it would be consistent over that time period. Sure,
So
hypothetically
wait a
speaking,
minute. So you're telling me that if we haven't measured it prior to 100 years ago, we can't say anything about what uranium was doing 200 years ago?
I mean, maybe you could. I don't know how similar the measurements are. I haven't looked at them. Have you? This is the thing. Like, have you
How
really questioned this?
how many times? So I've looked at uranium what is it called? Radioactive decay rate measurements. Some of which are very recent, and some of which are very old, like 70, 80 years old.
Okay, so 80 years ago. So okay, I'll give you. Okay, the uranium decay rate will stay the same within 80 years, probably.
But
And
why are
maybe
we
a bit longer too. Maybe a
just
bit
limiting it
longer
to 80
too.
years? I thought we just established that if you do the experiment enough times, then you can infer it, even in the setting that you haven't actually measured it in.
Um, no, I was saying with the gravity thing, you could go around pretty close with certainty, relatively, but across the world, no. And so, I mean, if you want to go back 80 years, you have measurements there. Maybe you can go back another 100 years, maybe. I don't
How
know.
many measurements would... So is it your view that we can't know anything about the rate at which uranium was decaying 500 years ago?
Um, how would we know? I don't know. Can we
That we can
know?
infer anything about it? Can we reasonably infer anything about the rate at
Well,
which
you're
uranium
saying,
was
I mean,
decaying
you're the
500
one
years
making the
ago?
claim that you can, right? Why am I on the defensive here? You're the
No,
one saying that you
I'm
can
asking you
infer it.
whether or not... Look, I can justify it. I'm just asking you, before I justify it, I'm asking you if you think that we can. If you think that we can. If not, then I'd like to know why you think not,
I don't
and I
think
can
so.
explain to you why we think we can.
I don't think you can.
Okay.
500 years. I don't, how would you be able to confirm that?
Well, look, so the whole business of science is we take data in the here and now, and then we use that to infer facts about the world elsewhere and elsewhen. And fortunately, things like decay rates, they're not just merely empirical things. I mean, like, perhaps they were 100 years ago, they were merely empirical things. We didn't understand why they decay at the rate that they do. We now actually understand why they decay at the rate that they do. These are essentially laws of physics. And unless you think the laws of physics were different 500 years ago, that gives us justification in thinking that if the laws of physics were the same, then the consequences of the laws of physics, like the uranium decay rate, would also have been the same.
See, this is where it's like, oh, the laws of physics. Oh, if you disagree with me or if you question me, you're questioning the laws of physics. I don't think you actually understand the laws.
I didn't say that at all.
That's what you said. You're basically saying, I'm paraphrasing, that you're saying that we know the decay rate extends past 500 years because the laws of physics dictate it must.
No, I said that we now understand the origins of the decay rate now, right? The decay rate now and the decay rate that we've measured in the last 80 years or so.
And that's
we understand
why
the origins of it. We can derive these decay rates. We can understand why they are the value that they are based on more fundamental laws of physics. These are no longer merely observations. They are now things that we can understand the origins of, right? And so if those origins merely come from laws of physics, then we have a good reason to think that if the origins are stable, then the outcomes will also be stable, right?
Yeah, I mean, you just explained. I mean, whatever. I think you just repeated basically what I said, but
do you agree that if the
terms.
origins are stable, then the outcome should be stable too?
Yeah, that's a big if.
Right. So then then it seems like your contention is you don't think that we can justifiably believe that the laws of physics were the same 500 years ago as they are today.
But that's you're assuming that you understand the laws of physics. I mean, what are these origins?
No, I'm assuming that they're consistent.
To predict decay rates. Please enlighten me.
So
I don't think you really. I think you just pulled that out of a hat.
The way that we understand decay rates is, I mean, it depends on the kind of decay rate. For example, alpha decay is quantum tunneling. You can model alpha decay via quantum tunneling, where you have an electromagnetic energy barrier blocking the alpha particle from escaping the nucleus, and you can predict the size of that that electromagnetic energy barrier based off the atomic number, and the atomic mass. And then you also need to make measurements about the shape of the atom as well, so then you can get something about the distribution of that nucleonic matter. That's one kind of decay. Actually, I think that uranium is an alpha decay. I think that it's an alpha emitter. So this would be the kind of physics that is used to predict the decay rate of things like uranium decay, and uranium decay in particular.
What's an alpha particle?
It's composed of, it's a helium nucleus. It's composed of 2 protons and 2 neutrons.
And the protons and the neutrons, those are quarks, right?
They're bound states of quarks, yeah. It seems irrelevant, though. Yeah. You don't need to know what the quarks are in order to understand how alpha particles behave.
I mean, so you're telling me you know what an alpha particle is and how it functions, but you don't even know what it's made out of, really?
Well, we do know. We know that they're made of protons and neutrons.
Yeah, but the protons are made out of quarks, and the quarks are the quark field.
But look, that's not about what the alpha particle is made out of. The alpha particle is made out of protons and neutrons. That's what the alpha particle is made out of.
But this is what I mean when I say you guys don't really go that deep, because if you keep zooming
you don't need to go deeper than it's made out of protons and neutrons to understand how radioactive decay works. No. In order to
is that like a forbidden
Jordan,
zone?
This
where
is
I'm
so
not allowed
bad
to go?
faith. Jordan, if I wanted to understand how, let's say I wanted to understand something.
Not allowed.
Jordan, let's say I wanted to understand something fairly straightforward. I want to understand. I'm just trying to think of something that's like super, super basic. Oh yeah, how about this? Let's say I want to understand why it is that, when I combine these 2 chemicals, actually no, why is it that I need to understand, what do I need to understand in order to figure out why it is that when I put a fire under an ice cube, it turns into water? What do I need to understand that in order to understand why that happens?
A lot. I mean,
really?
That's the thing. I don't think you really. I don't think anybody really understands how fire works.
Do I need to understand what quarks are in order to understand how ice melts?
You guys act like you have understanding, but you don't really.
Do I need to understand what quarks are in order to understand how ice melts?
Nobody really knows.
Do I need to understand how quarks work in order to understand how ice melts?
Yeah, I think so. Yeah.
Oh.
Otherwise, you don't even know what you're talking about.
Oh, okay.
It's just something. Like
so
you said, what is a quark?
You don't actually. How far did you get in physics? Because you said that you were studying it, right?
I dropped out when the professors were making me do dumb things for hours for no reason.
Are you talking about homework?
Matrix blocks. Like, what's the point of that? I can go on Google.
Are you talking about homework? You dropped out because the homework was too hard?
Yeah, I had access to Google. Why would I waste my time? And if I want to learn, doing these like jumping through hoops like a monkey for a cookie when I can just go on Google and talk to the PhDs right there? It makes no sense.
Wait a minute. I thought you dropped out. I thought you swapped out or left physics because
I was an engineer.
They didn't have a deep understanding.
And I dropped out twice because it was dumb, waste of time.
Wait, so what? So maybe I just misunderstood. So did you start as a physics major?
I started Bachelor of Science and then I went back for engineering and I dropped out of both.
And at what point did you drop out?
First year, full time.
First semester?
Well, no, second year, first time. Second year Bachelor of Science, first year engineering.
Mm-hmm. And you dropped out not because of a lack of understanding, but because of the homework?
Yeah, waste of time. I have Google.
So,
because I don't care.
Why'd you lie to me about
having
saying that you stopped paying attention to science because of the lack of understanding? It was because of the homework.
No, I was studying. I kept studying science when I dropped out. But I don't care about having a doctorate beside my name. I don't care about the badge. I care about the actual wisdom, right? I don't care if somebody at a university with a degree gives me a piece of paper. That's not what matters. What matters is the wisdom and the knowledge. And if you want the wisdom and the knowledge, you can go on Google.
You were studying it and then you stopped. I guess I inferred when you said studying that you meant like in like a formal setting. Do you think that like homework's not valuable? Do you think that the ability to do like math? All the time. Do you think that like the ability to do like mathematical calculations is not valuable for an engineer?
If it doesn't have a practical application, I don't think it's very valuable. No. If you're just jumping through hoops for no reason.
So matrix multiplication is like one of the most valuable things that like any engineer, any computer scientist, any scientist can learn.
Yeah, but only when it has. If you're just doing matrices in your room on a mountain by yourself, nobody cares. It has to have a
Well, because
practical application to the
the
world.
reason why they assign that homework is so that you can learn how to do it, so that you can reliably
Yeah,
do it
okay.
in the
What
future
if
when
I
you
learned
will
how to
have
do it in
to.
10 seconds, and then they give me 8 hours of homework? I already know how to do it. What's the point of that?
To make sure that you know how to do it.
There's
Because
no point. It's a waste of time.
I can assure you that if they just instructed you on how to do it and then gave you an exam on it, you probably wouldn't succeed.
But I get the general principle. That's the thing. I'm looking for the practical application. I don't want, oh, can you do, like, because
The
they take these
question,
equations, they make them so obscure for really no practical reason. They make them
how
so
can you know that it's
convoluted
not
with
for
so
a
many
practical
different.
reason if you failed to succeed in that degree? Are you
Because
an
there's
engineer
nothing
now?
being produced in the college. There's nothing being
Are
produced
you an
there.
engineer?
No.
Okay, so colleges, universities produce engineers, right? That's one of the things
Yeah,
that
but
they
they
do.
don't make products that are. Yeah, they don't make any products.
The engineers do. You wouldn't have
Yeah.
engineers
Okay.
if you didn't have
Does
education.
Elon Musk? Yeah, Elon Musk doesn't. Elon Musk specifically said he doesn't care if you have a degree. So I mean, there you go. One of the best engineers in the world doesn't care if you have a degree.
Elon
Boom. You
Musk
can do
dropped out
everything
of a
on
physics
Google. You can
program.
self-teach. You can self-teach. It's fine.
Okay, and self-teaching means doing the practice, right? Also, Elon Musk isn't an engineer; he's a businessman. So
self-teaching means focusing on the end result and getting
no, it
getting
doesn't.
an actual.
I mean, like this is neither here nor there. It's not really relevant to the
If you
conversation,
want to
but
get hired,
it does kind of illustrate your like the way that you think about these things, and it's kind of illuminating. But look, so it sounds like, just to kind of walk the question back, just so that we can get back on topic, it sounds like your contention is that we can't understand how, this is where we were, then I asked that question, we can't understand how ice melts without first knowing how quarks work.
yeah, pretty
And
much, yeah.
the reason why I asked the question how far you got in physics was because there's a whole business of, there's something called an effective field theory, which is like a more sophisticated way of describing coarse graining. Do you know what coarse graining is?
No.
So coarse graining is basically when you kind of throw away, not throw away, but when you kind of ignore, when you don't pay attention to information that is small scale, because all you need is the large scale average behavior in order to describe something adequately.
Adequately to you.
Yeah, in order to like make good
To who?
predictions about the way it
To who?
behaves, right?
Wait, can you repeat that?
In order to make good predictions about the way it behaves.
Yeah, I guess you can predict stuff generally, yeah.
So like if you want to have a good grasp on how things work, one good way to show that you have that good grasp is to be able to make predictions about how it will work in other settings, how closely related things will work. Because if you can predict the future, that must mean that you know something about what you're trying to predict, right?
Yeah, I guess kinda.
So
You know
you can
something,
throw
I guess.
away, all of the
Maybe.
information about quarks. You can throw away all of the information about protons, neutrons, about electrons. Really, if you want to make really, really good predictions, you might need to know stuff about like maybe thermodynamics, maybe statistical mechanics, maybe crystalline solids in order to make good predictions about how ice melts. But you absolutely don't need to know anything about
Right.
quarks. So to say that you
Right,
need
so
to know about
you're
quarks in
saying
order to
you're-
understand why ice melts just seems silly.
Well, I think, just because you can make some predictions doesn't, like, when you say how ice melts, just because you can make some predictions about when it's going to melt doesn't mean you actually understand it. How it's working, the mechanism behind it. Yeah,
But
maybe you can make some
the mechanism
predictions.
is
Okay, you know
fully
something about it.
the mechanism is fully accounted for by the coarse-grained information that you need, right? There is not a single piece of information that you need to know about quarks in order to fully describe, capture every single aspect of ice melting. You don't even have to think that you don't even have to know that quarks exist in order to fully describe how ice melts.
You can know maybe
fully characterize it.
You can predict you can predict the rate at which the ice will melt, but you don't know what, that doesn't mean you know what fire it, like, that doesn't mean you understand the process fully, which is what you're saying. You're saying
No, you do.
Like,
So the quarks are not involved in the process of ice melting.
that's ridiculous.
You can say it's ridiculous, but I urge you to find me one way in which not
prove that
knowing
claim.
about quarks would.
You just said quarks are not
lead you
involved
to
in the
the-
melting of ice. Go
Yeah,
tell
they're not
that to a
involved in the
scientist and
process.
see if they take you seriously.
Whether or not quarks even exist is irrelevant to the complete description of the way that ice melts.
So, are you backtracking on what you said? Do you think quarks are what did you say? Do you think quarks are irrelevant to the process of ice melting?
I mean, quarks make up things that make up ice, right? So like quarks are going to like they're going to be involved in the sense that like they exist, right? But the actual description of the way that the ice melt happens has nothing to do with quarks.
I would say a description, but not the, and definitely not the full description. The full description is definitely going to involve.
Okay, so I challenge you. I offer you a challenge. Find me one thing that you cannot account for with merely a molecular view of water that requires a knowledge of quarks to understand with as far as water melting is concerned. Sorry, ice melting is concerned.
I mean, you're the one making the claim, and you have to prove your claim. You're the one saying that. You're
So
the one
I just-
saying
I
affirmatively
laid
that
out to you this
you're
whole
saying
business.
everything is covered without quarks. You're the
Yep.
one making the claim, so you defend it.
And I already laid it out for you. I laid out what effective field theories are, how coarse graining works. I could give you a complete accounting of ice melting in terms of electromagnetic fields keeping atoms bound together towards each other, and the thermal distribution of energy causing the accelerated oscillation of those electromagnetic the accelerated oscillation of the atoms and molecules that make up water, causing those bonds to break, and that will fully account for the melting of ice without ever talking about quarks. Not necessary
I
at
don't
all.
believe that's full at all.
Okay,
Why-
give me an
how-
example
how
of
can you
one
say that's
thing.
full?
Give me an example of one thing that description will miss that
prove that it's
requires
full.
quarks.
I don't believe it's full. You're the one making the claim.
Okay, so you don't believe it, so give me an example of what it misses.
I don't have to. You're the one making
You just
the
made the claim that you don't believe it's full. Okay, what is it missing?
That's not a claim. I just don't. I'm not believing your claim,
Okay.
and I think your claim is unfounded. And I
Okay,
think
so
all
what- so
scientists, I think
what would
probably
you
every
need?
particle physicist in the world would disagree with
I'm
you.
sorry. So you're asking. So I could keep giving you more and more description, and you could always just keep saying, "Oh, that's not full. That's not full." So the claim,
that's
what
the
you're
point.
asking
That's why
me,
you're shallow.
what you're asking me to justify is something that you would never accept justification for. So rather than being bad faith and asking for justification when you would never accept justification,
Oh, I'm bad
instead
faith for asking
just
you to go
justify your
deeper.
own claim. Justify your own claim
If
that
you
that's
ask me
not
to go
a full
deeper,
not a full
you're bad
explanation.
faith. Trying to get a deeper understanding of reality is bad faith, according to you, right? Pointing out that there's gaps.
Suggesting
in your
that you
wisdom
need
is
to
bad
understand
faith.
quarks in order to figure out how ice melts, that's bad faith, yes.
You're saying that if you go tell a particle physicist that quarks are not involved in ice melting, they will laugh at you. They will say,
Want me to bring up a particle physicist?
Very funny.
Want me to bring
Yes.
up a particle physicist?
Well,
okay,
you guys
sure.
are all in a cult, so you'll probably back each other up because you don't really. I mean, come on.
One sec.
But
Let me pull them up.
If it was like, if you brought tell this person that I said it, and they'll mock it.
I'll just bring them up.
Yeah,
Then you can say
tell
it.
them that I said it though, because if he knows that you said it, he's gonna back you up. But if he thinks I said it, he's gonna go against me.
One sec. I just got to send him an invite. Alternatively, if there are any particle physicists in the chat, I'd be happy to bring you up. But I'm not a particle physicist, even though I played one as an undergraduate for 3 years. Actually, does that count? I did do particle physics for 3 years as an undergraduate. You there?
Me?
Yeah.
Oh,
Does
what?
it count? I did particle physics for 3 years as an undergraduate.
Oh, yeah, okay. Is everything you learned on Google?
Is everything I learned on Google? Probably not, actually.
What is
Some of the stuff I was doing was really obscure.
All the textbooks are available online for free?
The particle
Probably.
physics I was doing was not in textbooks.
Really?
At least I didn't learn it in textbooks. No.
You in like a classified military program or something?
No, it's just most research cannot be found in textbooks.
Where is it found then?
In researchers' brains.
Okay.
Things only get into textbooks like 50 years after the fact.
I just assumed it was 3 years of school, but you did 3
No,
years
no,
of
no.
research.
I did 3 years of particle physics. I was doing particle physics research for 3 years as an undergraduate.
What does that mean?
It means I was
So you're doing
involved
research
in.
for 3 years. Okay.
Yeah.
Cool. Congrats.
So does that mean that I'm qualified to say yes, quarks are not involved in the melting of ice? Am I sufficiently qualified for your view, for your opinion?
How can you say that ice is made up of quarks and then they're not involved in melting? Like what?
All right, so this guy, he hasn't been listening at all. Go ahead and say the thing.
Yeah,
Okay.
quarks are not involved in the process of melting ice. You don't need to
So
go
what
to
are
that
they
level of
doing there?
precision.
What are they doing when ice melts? They're just like, hey, protons, I'll see you later.
I mean, they're composing the structure of those protons, but they're not actually involved in that process. You don't need
They're not
that level of
involved.
precision.
They're just the fundamental building blocks of the entire structure, but they're not involved in the transformation of the structure.
Yeah, that's a
They don't
chemical
move.
process.
Do they move at
not
all?
A nuclear one.
They don't move.
I mean, they move
Do the
with
quarks
the
move
atoms,
ever?
but you don't need that level of precision.
Are they involved? they
Involved
move?
only as so far as that they are just composing the structure. But
so
the actual
the structure
process
moves.
themselves, that's a
I would say
chemical
that's-
process,
so-
not a nuclear one.
So when ice melts, the quarks, do they move?
They move with the atoms.
Oh, so they're involved then, because they move.
They're not actually like involved in the process. You don't need to
Oh,
resort to
they're just moving
a strong
around
nuclear
everywhere
force
changing
to actually describe
temperature.
the process.
Yeah. Okay. This is such cope.
So,
Can you show me like a
I don't know what
scientific
about this
research
hard
study
drive.
that proves that quark? I mean, it's just such an insane baseless.
So a particle
claim.
physicist,
And that's,
somebody
that's,
who's
that's what I'm saying. That's
doing
what
his
leaves the bad
PhD in
taste
particle
in my
physics,
mouth,
just came on and said,
this is the standard.
yeah, you're
you
wrong
guys
about
have.
quarks.
This just exposes your standard because you just make baseless claims. It's like, well, if you're going to make claims like that, then clearly
look,
all of your claims are
Jordan,
garbage.
you made the claim like not 5 minutes ago saying, go tell this to any particle physicist in the laugh in your face. So I brought on a particle
this
physicist
guy's
and he
just
agreed with me.
dishonest. Whatever. Okay, I was wrong about that claim. Oh no.
All right, Quanton, I'm kicking
You're
you off,
missing
but
the
thanks
point,
for
bro.
thanks
This
for
guy's
doing that.
not honest. You're both
Okay,
just
so
lying to yourself.
now it's not. Oh, you're just wrong. Now it's, oh, the particle physicists are being dishonest. That's a cool goalpost shift.
Do you think this is a victory for you? I mean, it's ridiculous.
Yeah, I mean, you look pretty bad.
This guy, this is your henchman. You brought your henchman
Is
up.
my henchman?
Hey, look, I got my henchman here. He agrees with me. I got my yes
He's a
man
particle
here. He
physicist and a
agrees with me.
friend.
You're missing the point completely. You need a blind study. Your bias is shaping his answer, and that's why he answered that way. If you gave a neutral request to a particle scientist, a particle physicist, he then I bet you it would be right. But you loaded it with like.
Have you ever talked to a particle physicist before?
Then that would have caused drama.
Have you ever talked to a particle physicist before?
Yeah,
Do they have a name?
Dr. Blitz.
Oh, okay. So wait a minute. So I'm the only particle physicist that you've ever spoken with.
I don't know. No,
I'm
probably
not still
not.
a particle
No.
physicist, by the way.
I've
Like
been on
maybe I
Reddit
was
quite a
as an
bit.
undergrad, but I'm not anymore.
No, I used to troll around the physics subreddits and yeah.
So you've never talked
Probably
to
not.
a particle physicist?
No, I think I have.
Well,
But whatever. Why
so-
does it matter? Is that
well,
like a big win
look,
for you?
because you're making
How
assertions
many-
about
well,
what
I
a particle
talked to 10
physicist would
particle
say.
physicists, so I'm right.
No, Jordan, the reason I ask is because you're making assertions about what a particle physicist
I
would
own
say.
10 Bibles.
You're making assertions about what a particle physicist would say without A, knowing any particle physics, and B, knowing any particle
'cause
physicists.
No, my assumption is because it's so obvious that quarks are involved. It's such a
Or
ridiculous
alternatively,
statement.
you're wrong and you're experiencing the Dunningest of Krugers because you think that
No, you
something
have a
is obvious
cult
when you're not
of yes
educated on the
men.
matter at all.
You have a cult of yes men who will agree with you no matter what, and that's why everybody is in your chat is saying that quarks are not involved. He's right because you have.
Is
like
it possible that you're wrong about this,
a
Jordan?
cult of personality. Pardon?
Is it possible that you're wrong about this?
I don't even know what a quark is, bro. I don't even know. A quark is just a label.
Is it possible that
like
you are wrong?
I would say it's possible I'm wrong about everything, and it's possible
Okay.
you're
Is
wrong
it
about everything.
so?
A quark is
Is
just
it
a label you
plausible?
put on
Is it
something you
plausible that
measure.
you are wrong about particle physics, as far as ice being involved in ice melting? Is that plausible?
I mean, I'm not even really making a claim about. I mean, I guess my claim is that, yeah, okay, definitely. I would say it's definitely possible that I'm wrong that about my claim that
Plausible.
quarks must be involved in ice melting, because I don't even know what a quark is, bro.
Plausible,
You didn't
not
even explain a
possible.
quark.
Plausible.
It's plausible, yeah.
Okay. So how do you establish, if it's plausible that you're wrong about this, why would you so certainly believe the opposite with such confidence?
Because the only reason I think I'm doing an internal critique, but it's possible that I shouldn't be internally critiquing. Like, it's possible that the whole so when I'm saying
I'm not asking like, are you a brain in a vat? I'm asking, could the particle physicist be right about this, and could you be wrong about this?
I'm saying, wait, the particle physicists. I mean, you mean you and that other guy?
Yeah, and all of the particle physicists that I've ever spoken with that would agree with me.
No. The internal critique is, I'm giving you that quarks exist. I'm letting you have that.
Mm-hmm.
And the way I could be wrong is if quarks don't even exist. That's what I mean when I say I could be wrong.
Yeah. So you're saying that given that quarks exist, you could not be wrong that quarks are involved in the process of ice melting?
Yeah.
Or that.
Yeah.
Actually, let me rephrase. Given that quarks exist, you're saying you could not be wrong about the necessity of understanding how quarks behave in order to understand how ice melts.
Yeah.
Okay. You don't think that's possible that you could be wrong about that?
No, I don't. No, because a full description.
So you are 100%
contain
certain, you'd
quarks.
say, that given quarks exist, then
given that,
it must be the case. It is impossible for you to be wrong about this claim that you need to understand how quarks work in order to understand how ice melts.
Yeah, because you set the groundwork that quarks. You set the groundwork that ice is made of quarks, right? So if ice is made of quarks, then you have to understand quarks to understand ice.
No, you don't. That's the point.
Okay, says some guy.
I mean, like, I explained this whole business about coarse graining. It seems like it went in one ear and out the other ear.
I mean, so you're just talking about reducing the resolution to say some things. I'm saying I agree. You can say some things about ice, but that doesn't.
You
mean
can fully understand the process using coarse graining.
Yeah,
you don't need to. You don't.
You said
the other stuff is not. The other stuff is not necessary to understand it.
I don't believe that. I mean, I don't believe that. There's a difference between knowing some things about the process and knowing everything about the process. And you're saying you can know everything about the process.
Do you understand, how you get to the grocery store, on Saturdays?
No, everything's a miracle.
Do you understand anything,
point, bro? No, nobody does. Neither do you. That's
Wait a minute.
My problem.
Hold on. Just to be clear, Jordan.
Pretend like you understand everything.
I'm willing to grant that you don't understand anything. I don't think that you should assume that about anybody else.
It's obvious. You don't know what you are. You don't know where you came from.
I think that you're just impugning your lack of understanding on other people.
You're just pretend. Your whole worldview is pseudo. It's pseudoscience. You pretend like you understand, but you don't. And that's my problem with science. Is what are you? Oh, I'm a bunch of quarks. What are quarks? Oh, I don't know. It's a field. It's a thing, a field thing. It's space. It's points in space. What's space?
It sounds
I don't know. It's over here. Look, I'm pointing at the quarks, guys. Woohoo! Come.
It sounds like your entire view is based on you not understanding things, and therefore nobody could understand things. Because you think that you're the smartest person in the world, and if you don't understand something, it must be impossible, and everybody else is just being dishonest.
And you think if you pretend like you're super smart and you have a doctor beside your name and a PhD, oh, I must be smart. Look at me and all my smart friends are going to school together. Look how smart we are. Come follow me. I'll take you to the promised land.
Am I intimidating for you, Jordan?
Science is so great, guys. Come along.
Jordan, am I intimidating you?
Calling the kids into the cave. Woohoo! Come here, boys.
Is my education intimidating for you, Jordan? Because it doesn't have to be.
No, it's a dead end. You're gonna be in the dirt. Nobody's gonna care, and that's what my problem is. It's like, oh, like you're not that smart. Your wisdom is not that deep. It's not that valuable. You don't really understand anything, period.
This
You don't
sounds like
understand
cope.
what you are. You don't understand what you are, right? Do you?
It sounds
What's
like
a
cope.
proton? Oh, a proton is a quark. What's a quark? Oh, it's right here. I'm pointing. That's what you did, bro. That's how deep you go.
So
You're
your
exposed.
worldview amounts to nobody knows anything, we can't know anything, so let's just believe in Jesus. Sounds like.
No, first of all, I want to establish that you know nothing, and then once
Well, you haven't
you
done
get
that.
tired of floating in
but-
the abyss, yeah, maybe then you would reach out for Jesus.
I mean, you haven't
once you
established
realize you're
that.
floating in the abyss of nothingness, then you'll look for a light. Yeah.
And surely that's what you did. You
Yeah.
dropped out of a science bachelor's because the homework was too hard. You went back for engineering. You dropped out of that because the homework was too hard. And then you realized that, you know, all this is useless. Scientists don't know anything. I found my way in Jesus. Is that right? A good estimate
I
of your
started
life
reading
story?
the Bible, and I was like, "Yo, this is banger after banger." He said, "Don't
But you
worry
can't
about
understand
this life,
any
what
of
you're
it.
gonna
What are
eat."
you talking about? How do you understand any of it?
Through faith.
Oh, but faith
Because I
isn't
find
certain.
Jesus-
How can you know anything?
I just find it more. I'm not saying it's certain. I just find it more compelling.
Oh, but
than
you don't
your
even understand. You don't even
scientific nerd
understand the words.
cult. I'd rather hang out with Jesus than a bunch of nerds and who die. I'd rather go follow him. I find him a lot more compelling than you. If you're searching for wisdom, I don't think Neil deGrasse Tyson's gonna save you, bro. I don't think Sheldon from Big Bang's gonna save you. You need something more.
Can you name
I
a
mean, I'm
physicist?
not saying I'm certain, but I find Jesus a lot more compelling than you because he has a plan. He's going to come back, save
Oh,
the
but
world.
how do you know?
Immortality.
How do you know that was Jesus? How do you know
I
that?
don't know.
You know that.
I don't know.
So
I
then
don't
why
have a
do you
math
believe it?
equation
You
for
just
it.
don't understand anything. You don't know anything.
Exactly. I don't have a math equation for. I can't go a squared plus b squared.
You don't even know
equals
if Jesus
is real.
existed.
It doesn't work like that. How do I know?
No, you don't know that Jesus existed.
Oh, not for sure. I can't prove it. No.
No, you don't even. You don't
But I
even.
find it more
You have no
compelling.
understanding of Jesus' existence. You
No,
don't know
not
anything.
really. But I'm building on him spiritually, right? And
You're
and
building
maybe
on
I'm
something.
wrong.
So you're
Maybe-
building on a scaffold that you don't even know exists. You're building on a scaffold that you don't understand. That seems irresponsible.
And so are you. And you want to bet on Neil deGrasse Tyson?
That's what
I'll
you're.
bet on Jesus.
That's what you're. That's a description that you are giving to my view. That's not my view, but it is your view that you don't know anything.
Well, you're coping.
So your view,
because you are building on nothing.
your view is that you don't know anything, and then you're building on top of that lack of
No,
understanding,
my view
lack
is
of
that
knowledge.
you also don't know anything.
Well, yeah, but that's an
That
external
was the
critique, not
whole
an
point.
internal critique.
Okay, what are you then? Oh, I'm the cork field. Look at the cork, guys. It's a points in space. Everybody follow me. Follow me to Corkland. We're gonna meet Smurfette and Smurf King in Corkland. Like, it's just ridiculous. So you're building
Incredulity
on
is
nothing,
not
I'm
an
building on
argument, Jordan.
Jesus. You can't prove your worldview. I can't prove my worldview. I'm gonna bet on Jesus. You bet on Bill Nye, and we'll see who's right.
No, I'm going to bet on evidence.
Evidence of what?
Claims?
All the evidence shows that you're going to the dirt, and nothing you do will ever matter. So enjoy that.
All the evidence shows that, like, the sun is made of hydrogen, for example.
Wow.
Mostly
big
hydrogen, a
win
little
for
bit of
you.
helium.
Yeah, what about immortality with Jesus in heaven and all of your
But
loved
where's the
ones
evidence
brought
for any of that?
together? I've seen enough evidence. The Bible says seek and you'll
Wait,
find.
so
If
do we
you don't wanna
believe?
seek,
Do
you
we
won't find.
do we need evidence now? Do we trust evidence or no?
I think evidence is good, but when you take it too
you
far,
do
like,
think evidence
again,
is good. What does evidence get you to? Does it get you to justified belief?
it doesn't get you to 4.5 billion years.
It sure
It doesn't get you
does.
there.
Sure
No,
does.
it doesn't. It says your cult. It says your indoctrination.
What's the evidence for 6,000 years?
I mean, I just find it more. I find the Bible as a whole more.
What's the
compelling.
evidence
I
for
find
6,000 years? I don't care what you find compelling. What's the evidence?
Oh, I haven't looked at. I don't look at it. Like, I haven't done any math equations for it.
So you just believe it.
If that's what you mean. Pardon?
So you just believe it without evidence. I thought you said you cared about the evidence.
Well, I have evidence for Jesus, but it's.
But you don't
personal.
have evidence for the Earth being 6,000 years old.
No, but I think.
But you just believe it.
I mean, but when you talk to scientists and they're super shallow and vapid, it's really easy to throw away what they say. And when I listen to Jesus, he's like really smart and caring.
Wait, does
and loving
Jesus
and
say that the
helpful.
Earth is 6,000 years old?
Yeah, there's genealogies right back.
Oh,
to
where
Adam.
does Jesus say this?
in the genealogy of Matthew.
Wait, so Jesus gives the genealogy?
Well, it's in the book of Matthew, but
Oh, so Jesus doesn't say it.
no, I guess Jesus didn't. No,
So then why do you believe it?
because I find the Bible more compelling than all of your scientific.
So
diversions
because
that
you
lead
like
to
it
nowhere.
more? Sounds like.
Yeah, pretty much. Yeah, especially because
Sounds like a great way to form
I listen to
beliefs.
what you guys are saying, and it's all just kind of like, okay, cool, you're gonna die. Congratulations, you did it. Woohoo, you're atheist.
Oh,
Yay.
so this was all cope.
You're coping, bro.
Did you just know Yumi?
I mean,
Because
yeah,
like,
I
look,
guess
it
so,
seems like that you just don't like the fact that, you know, if you believe the scientific consensus, then yeah, death is permanent. That there is not a feature of you that moves on. There's not some feature of you that moves on to the next world or whatever. It sounds like that this is just like mortality cope.
it's definitely part of it because it's like, if you're so smart, you can't even stop yourself from unaliving. Like, clearly that you're missing a big piece of the puzzle there. You know, maybe there's something else.
So you think that because scientists can't make you live forever, it all has to be wrong?
No, I don't think it's all wrong. I think
Just the stuff that you disagree with.
repeatable things. I think, you know, if you
know what's
gravity.
repeatable?
Gravity seems pretty reliable.
You know what's
That's
testable?
probably right.
The permanence of death. That's testable.
I mean, according to your inference, yeah, I guess, right? I mean, if you're gonna
Have you ever
infer
seen someone come
uranium
back from the
decay, then
dead?
you better infer death too, right?
Have you ever seen someone come back from the dead? And I mean like dead,
No.
not like they were being like resuscitated by a doctor. I mean like dead, like not breathing, no brain
No, I
function
haven't.
for days.
No, I haven't.
Okay, so you're not justified in believing that that's ever happened?
Not by like a scientific
By your standard, are you justified in believing that that ever happened?
by my standard? Yeah. I
thought,
think so. Dude,
hold on. What's that standard?
My experiences, really. Do you think there's a spiritual world at all? Do you think
No.
there's a higher existence, aliens, spirits, anything like that?
No, I don't. And I think we're done.
Time to play.